Hello, ladies and gentlemen. Today we're going to be taking a look at Newton's first law of motion. Yes, the word first does imply that there is more than one. There are three in total. Today we are starting with the first of those laws. And what does it say? Well, Newton's first law of motion, perhaps this sounds familiar to you. Maybe you've heard it before, but an object at rest stays at rest. An object in motion stays in motion at a constant speed and in a straight line unless acted on by an unbalanced force, excuse me. So we have just kind of wrapped up talking about this idea of balanced and unbalanced forces. And we talked about the fact that when unbalanced forces are working on an object, it causes movement or motion or a change in position, right? Um, so here we see the connection between Newton's discoveries and this idea of unbalanced forces. So an object is always going to stay at rest uh, unless, if it's already at rest, unless an unbalanced force acts on it. An object that is in motion is going to stay in that exact same motion. So it's going to stay at a constant speed and in a straight line unless it is acted on by an unbalanced force. Once an unbalanced force is applied to that object, if it was at rest, it's going to move. If it was in motion, that motion is going to change. All right. So, real quickly, an object at rest is, of course, not moving. I think that's probably fairly obvious, but let's just make sure. All right, so an object at rest is not moving, such as this golf ball that is sitting on the tee. All right. Objects at rest, such as a chair, a desk, a book, are not going to move by itself unless there is a force applied to it, okay? It's just not going to move unless there is some sort of force that has been applied. All right, take a look. Here's a golf ball again. Okay, this golf ball is at rest. It is not moving. An unbalanced force, however, of a golf club being swung, if it applies a force to that golf ball, then that golf ball will be moving. All right, so we've looked at objects at rest. That's the first part of Newton's law, is an object at rest stays at rest. Let's take a look at objects that are in motion. So moving objects are going to continue forever in that same motion, that same velocity, that same direction, unless an unbalanced force acts on them. Okay, now we know that objects don't stay in motion forever. Okay, because eventually an unbalanced force acts on it. However, uh, the law tells us that it would stay in motion forever if an unbalanced force did not act on it. So I think we've all experienced, well, maybe not this exact scenario. All right, so let's say you're riding in a bus to school. Uh, you finished your candy bar, you stand up and you start walking toward the front of the bus to throw away your candy wrapper, despite the fact that you know this is a highly unwise and unrecommended thing to do. Suddenly, a mouse runs in front of the bus. The bus driver slams on his brakes because he is particularly fond of mice. What is going to happen to you and why? All right, pause the video for one moment and talk to your neighbor a little bit about what is going to happen. Okay, so hopefully you've had a chance to chat with someone about what is going to happen to you when the bus driver slams his brakes on to save this little mouse. Okay, you are going to continue in motion. You were in motion. Your body wants to continue in motion. You had the same motion as the bus as long as you were sitting in the seat of the bus. Um, Even as you were standing and walking, your motion was basically the same as the bus. You were in motion going forward. Suddenly, the bus stops. You Do not, because you are going to stay in motion until you are acted on by an unbalanced force. That unbalanced force could cause you harm, which is why you should not be standing up in the bus walking around. All right, that is why we stay in the seats. Perhaps you have experienced the phenomenon as you are riding in the car with your parents, they make a sudden turn. Okay. And when you do, you like slam into the door of the car because, they made such a quick turn and you weren't expecting it. Well, kind of what happened, you were just continuing in the path that you were on. The car, as it turns, kind of slammed into you, actually. So you really could blame your parents for that. All right. We'll talk more about this idea a little bit later on. So let's talk a little bit about the idea of friction and Newton's first law. So we know that Newton said that an object in motion will stay in motion forever unless acted on by an unbalanced force. But if you push your desk, please don't do that, okay? But if you pushed your desk, what is going to happen? Well, is it going to move forever? We all know that no, it's not. If you push the desk, it is eventually going to come to a stop, right? What is it that causes it to stop? What makes it stop? Well, I think we all realize that if you push an object, most of the time, the reason it comes to a stop is because of friction. Now, sometimes it could be an impact force if it runs into a wall or something or another person before it fully comes to a stop because of friction. But most of the time, it's probably going to come to a stop because of friction. So friction is one of those unbalanced forces that is often at work at objects that cause them to not actually be able to move in at a constant speed and in a constant direction forever. All right. So you've done a little bit of reading, I think, on the word inertia. So let's take a look at um, what inertia really is all about. So sometimes Newton's first law is actually called the law of inertia. Inertia is just the tendency of an object to resist being moved, or if the object is moving, to resist a change in speed or direction until an unbalanced force acts on it. All right. So inertia, oftentimes people want to say that inertia is a force. Inertia is not technically a force. Um, Inertia is just a word we use to explain a phenomenon for all intents and purposes. Okay, so objects that are at rest do not want to move. An unbalanced force has to act on it in order for it to move. It's not just going to move on its own. And so inertia explains this tendency. Okay, another way to say it, it's the tendency of an object to resist any changes in motion. The tendency of an object to resist any changes in motion. Think about it. In the morning, when it's time to get up, your alarm goes off or your mom yells or something. Okay, what is your tendency to want to do? To stay right where you are, right? Okay, your tendency is not to want to get up. Mass and inertia are extremely closely related. It's almost as though they're the same thing, but not quite. So they're related in that the smaller the mass of an object, the less inertia it has. So light, weight, or small objects, although size doesn't really have to do with it, it has to do with the mass. How much stuff is it made of? Um, but these light objects are easier to move. In other words, they have less inertia and they're easier to stop moving because they have less inertia, less mass. Uh, Heavy objects, large, objects with a lot of mass, these are harder to move. And they are also harder to stop from moving because they have more inertia. They have a greater tendency to keep doing what they're doing. If they're moving, they're going to keep moving. If they are at rest, they're going to stay at rest. Uh, all right. So, whoops, sorry. It kind of is related to this idea of static friction as well. So that extra force that it kind of takes to overcome static friction sometimes has to do with the fact that uh, that an object has more inertia, it has more mass. Um, Sometimes it also has to do with the interaction of the surfaces between the two objects, but in some ways, static friction is kind of related to this idea of inertia. All right, ladies and gentlemen, we're going to be talking about more about this Newton's first law and inertia over the next couple of days. Have a great day.